This is lesson 2.7 of your chapter 3 notes, where we've been talking about lines and equations of lines and how to graph them. And now we're going to talk about how do you graph inequalities when they have a y and an x in them. For example, you've seen things like x is greater than 5, or x is equal to 5, or x is greater than equal to 5, and we've graphed them like this. We said that if it's simply an x equals, like this one, you mark the 5 and you just put a dot. When it's x greater than or equal to 5, you mark the dot, but then you shade everything above. Similarly, when it's x greater than 5, it's the 5, but open circle and everything above. It's going to be the same idea with our two-variable inequalities, except now then not just a number line going left-right, but it's a coordinate plane going left-right and up-down. So you're going to see things that look like y is greater than 3x plus 1. We talk about having boundary lines, and that simply means the line, like the mx plus b part. It's going to be solid when you have a greater than or equal to, or a less than or equal to. This is the closed version where you would see dots, filled in circles on your line. You will see dashed boundary lines when you have simply less than or simply greater than with no equal symbol. These are what you would call the open circles. You're going to shade above your line. So for example, you're going to have some line either solid or dotted, and you'll be shading above it when it's a greater than or a greater than equal to symbol. And you will have some line, again, dotted or solid, shading below when you have a less than or less than equal to symbol. Let me show you what I mean. Take a look at your first example here and take a look at the sign. This is a greater than symbol. So first of all, that tells us that we're going to be shading above the line. And there's no equal sign, so we know that it's going to be open or dotted. And then the rest of the problem is how you would normally graph a line. So we have 3/2 x minus 5. We'll start at negative 5. The slope is 3/2, so we'll go up 3 over 2, up 3 over 2, and we're going to make it a dotted line. And then we're going to shade above because it's a greater than symbol. So this area on the graph, the shaded area, represents all solution points for this inequality. Just because this is our first one here, let's take a look at some of the points on the graph. Notice the point 0, 0 sitting right there in the center. It's shaded, which means that 0, 0 should make this inequality true. Let's try it. If we plug in 0 for y and 0 for x, we'll have 0 is greater than 0 minus 5, or 0 is greater than 5. 0 is greater than negative 5. Is this a true statement? Yes, this is true. That's why that point is shaded. Now, if you choose a point that's not in the shaded section, let's say you chose this point down, the point 2, negative 1, 2, 3, 4. If we tried that point, negative 4 for y, 2 for x, we would get negative 4 greater than 3, negative 5, which is negative 4 greater than negative 2. And we go, no, wait, that's false. Of course, negative 4 is not greater than negative 2. That's why that point is not shaded. If you choose a point that is directly on the line, like this point right here, it's a dotted line, that point will also be false for this inequality. It will not satisfy. All right, here's another example. F of x is greater than or equal to negative 4x plus 1. Now remember, f of x is just another way to say y, so this is the same thing as saying y is greater than or equal to negative 4x plus 1. First of all, look at our symbol. We can see that it's also going to be shaded above, and we can see that this time it's going to be equal to, so it will be a solid line, because that equals symbol. So go to your b value here, which is 1. Our slope is -4, so down 4. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. There's our line. And shaded above that line, this ways. Yay. Again, test to see if we did it right or not. A good point to check might be a point like 1, 1. That looks like it's in the shaded area pretty clearly. So if I plug in 1 and 1, we have y is greater than or equal to -4 times 1 plus 1. So 1 greater than or equal to -4 plus 1. 1 greater than or equal to -3. It's true. So it's shaded. We're good. Here's an example where your equation is not solved for y, so you have to rearrange it to get it in the right order. To do this, we'll go ahead and we'll move the 3x over. So we get 4y is less than 3x minus 6. Divide everything through by 4. So we get y is less than 3/4 x minus 3/2. Again, our symbol tells us that we will be shading below this time and that it will be dotted. Now to start at -3/2, that means here's 1/2, here's 2/2, here's -3/2 right here. That's our dot. We need to go up 3 and over 4. So up 1, 2, 3 over 1, 2, 3, and 4. Notice I'm landing in the middle of a tick mark because I'm starting in the middle of a tick mark. This is a dotted line. And this time I'm shading below. Now to test for a good point to see what would be true, we could use the point negative, let's use 4, -2 in here. So if we use 4 for x, -2 for y, we end up getting -2 is less than 3 minus 3/2. 3 minus 3/2 is 3 minus 1.5, so just 1.5. Is 1.5 greater than -2? Yes, it is. True. Okay, good. We're on the right spot. You can also see these types of graphs with things other than straight lines. You might see an absolute value symbol. Remember when we talked about the translation, something on the outside is up, down, so this is going up 1 unit. Something on the inside is going left, right, and this one is not going the way you might think because of the plus sign, but it is going left 3 units. Remember, it's always opposites for the inside pieces. And then this piece here means that it's a reflection across or over the x-axis. So we'll go up 1, left 3, and then it's going to come downwards because of that reflection facing down. Notice that I made it a dotted line because of this symbol, and then it says it's greater than or above, so we'll shade everything above this absolute value. Okay. 2 other quick notes for something that you might see in your homework. Used a little bit of space down here. In your homework, you might see lines that say x is greater than or equal to 7, for example. And when you're talking about the coordinate plane and you see the x symbol, that means you go to the 7. 1, 2, 3, 4, 5, 6. Here's 7. And we're saying that x, so for all x's, we don't care about y's. It's a straight up and down line. Notice it's solid because of the equal symbol. And then it's greater than, so we're going to shade to the right of that line because that's greater than 7, values like 8, 9, and 10. The other thing you might see is if you see a y equals, you might just see a y, let's say, is less than 6. So on your graph, you go up to the y equals 6. 1, 2, 3, 4, 5, 6. There it is. Dotted line. And less than here, so shade below. So those are the 2 special cases where it's just an x, it'll be an up and down line. Where it's just a y, it'll be a straight side to side line. For this last example here, there's also an absolute value. We have not talked about what a 2 does on the front inside here. And so if you ever get to a problem and you don't remember what to do, or you don't remember which way something shifts, you might go, oh, well I know this moves it down 3. Well, yeah, it does. We still don't know what the inside does. And if you're ever stuck, you can just do a quick XY chart to help yourself. So we're going to do a quick -2, 0, +2 chart and plug in our values. So -2 times 2 would be -4, but that's an absolute value, so it makes it +4 minus 3, so +1. 0 times 2 would just be 0, so -3, and 2 would be 4 again, minus 3, so 1. So let's see if we can use these points here to help us. 0, -3, -2, 1, and 2, 1. Yep, that gives us enough of a shape. We know that we're looking at a solid line because it has the =2 symbol. And we also know that we are shading above that line. So we are shading everything inside of the absolute value for this one. Everything greater than. All right, last thing is you are given two graphs and you're asked to write the inequality. They've given you the boundary line, meaning this is the equation for the absolute value shape you see here, but we have to figure out what symbol we need to place in here because we know it's not =2, that would just be the line. So we're going to copy y and then absolute value x minus 2, absolute value minus 1, and we need to figure out, first of all, which way it's going. So it's going upwards, so it's going to be a greater than symbol. And it's dotted, so I'm just going to leave it. I'm not going to put any =2 sign underneath of it. Same thing for this one. Here's the boundary line, y equals -1/2 x plus 3. And we have to figure out what symbol. So this one's going downwards, so y is less than. It's also a solid line, so we're going to put the =2 symbol. And that is all they're asking for. They're just asking us to figure out what symbol to substitute in the equation.